Hi Year 12, been a few questions regarding the directing group work. I thought I'd spend a few minutes just going through and clarifying some of the issues, as this does get used extensively within the synthetic pathways and the different routes we have to use. Mainly involves the electrophilic substitution of benzene, and in simple terms, it's where does the second group that is substituted onto the ring end up. Now, any group on a benzene ring will have an effect here. In our course, we just need to know about three different groups: OH, NH2, that are both what we call 2,4 directing, and NO2, which is 3 directing. Okay, so if we have a phenol or we have an amine, if we add something to the group, whether it's a Cl, a CH3, a Br, an RCO group, it will be directed to carbons 2 and 4. When we say carbons 2 and 4, we are numbering the phenol or the NH2 as carbon number 1, and then we go around clockwise or anti-clockwise. It really does not matter. Okay, so that means that is the phenol is on position 1, position 2, 3, 4, all the way round. Okay, sometimes you might see it as, these are also known as ortho, meta, and para. Okay, so if something is ortho and para directing, it is 2,4 directing. If something is meta directing, it is 3 directing. So in our course, a phenol group and an NH2 group will direct secondary additions to carbons 2 and 4, and the reason is that OHs and NH2 donate electrons to the ring, and they basically activate it, whereas NO2 groups are what we call electron withdrawing groups, so they draw electrons that way, and the consequence of that is they become less reactive, and the second substitution position will be at carbon 1, 2, 3. So if we were to react this now with chlorine and a halogen carrier such as AlCl3, our product would look like NO2, and our chlorine would go on there, and we would obviously lose our substitution product. Okay, and it's used extensively in synthesis. Now you've got to be careful here, because you can convert an NH2 group, or you can produce an NH2 group from an NO2 group, and it's when you oxidize the NO2 to NH2 that is very important, because NO2 will direct to position 3, NH2 to carbon 2 and 4. Right, so there are a few examples in the homework the other day. The first one was NH2Cl. Now, if we're making this from benzene, I believe if we put the chlorine on first, that chlorine is 2,4 directed. But there's an easy way of doing that. So the first thing we're going to do is we're going to take our benzene and we're going to nitrate it. Okay, and if you're nitrating it, it's nitric acid concentrated with sulfuric, our catalyst, and that produces NO2. Okay, and H+. Now, if we were to react that with the chlorine now, NO2 is 3 directing. It would end up there. Well, that's clearly not where we want our product. So what we're going to do now is we're going to reduce our NO2. So we're going to go NO2, and the reduction mixture is HCl and tin. Tin is a catalyst, and that's going to reduce it to our phenol amine. Now, phenol amines are 2,4 directing. So if we take our phenylamine, there will be two products here because it directs to both. Okay, and we're going to add our Cl2, and we're going to use our halogen carrier. It will make two products, NH2, and that's carbon 1, 2, 3, 4. So it will make some where it has gone in there, and it will also make some where the chlorine is there. And I think they'd be roughly in the ratio of 2 to 1, because there's only one 4 position, where in effect there's two 2 positions, because also that there would be a 2. Okay, if we'd have reduced the NO2 afterwards, we would not have got the same, because if we reduce the NO2 afterwards, it would have directed to position 3. So let's try another example of this. Right here we have 1, 2, 3. Or if you want to do it, if we're going to put the nitrogen on first, we could say, well, the nitrogen is very much carbon 1, carbon 2, carbon 3. Okay. Now the only way we get the nitrogen on in the first instance is nitration, so we're going to react this again, nitric acid with our conch sulfuric, and that's going to produce nitrobenzene and an H+. Now remember, nitro is free directing and we want our chlorine on position 3. So this time, rather than reduce it first, we're going to chlorinate it. So we're going to add chlorine, and we're going to have our halogen carrier on there, and that's going to make that. And then what we're going to do now is, now we're going to reduce our nitro group. So we're going to say NO2, but it's not NO2 because we've reduced it, haven't we? So, whoa. Bear with me. So what we're going to do is we're going to get rid of that, as we should have done earlier, and we go blue and there, perfect. And we're going to say we have our NO2 and our correctly placed chlorine, and we're going to reduce that. We're going to add some HCl, and we're going to use a tin catalyst, and we're going to end up with NH2 and Cl and H+, and that's exactly what we were looking at. So the key here is, more than anything, when do you reduce your NO2 group to NH2? Okay, so last example was here. So we've got NH2 in position 1, and we've got our acyl group in position 1, 2, 3. Okay, so we need to add a nitro group. We then need to react it with or acylate it, because the NO2 group that's on there will direct it to position 3. Then we're going to reduce our NO2 to NH2. So first thing we're going to do is take benzene, and we are going to nitrate it. So we're going to add HNO3 with our conch sulfuric catalyst, and that is going to give us nitrobenzene. Okay, now NO2 is a 3 directing group, and that is carbon 1, 2, 3. So we're not going to reduce the NO2 to NH2. We're going to acylate it with we're going to react it with Cl, CO, CH4, 3 and a halogen carrier, and we're going to produce NO2, and that NO2 is going to direct the acyl group onto carbon 1, 2, 3. Okay, and now we can reduce our nitro group using tin and conch sulfuric acid, and that will give us NH2 and CH3O. Okay, so the only groups you need to worry about are the 2,4 directing groups. Now the 2,4 is NH2 and OH, and the easiest way to remember the phenol is if you react phenol with bromine, you get 2,4,6 tribromophenol, and carbon 6 is in effect the same as carbon 2. And the other group you need to know about is the nitro group, NO2, and that directs to carbon 3. Okay, and all you're going to do is use either this group or this group to direct where you need to be directed to, and then oxidize, or sorry, it's actually reduce or reduce as and when. Okay.